In our today's class, we are going to look at the question displayed on the screen. The question says, find the value of n in the below. This question is an exponential equation. Now, to find the value of n, we are going to write solution. Then, if you look at the question very well, you will see that you have two different numbers there. We have two different, let me put it this way, we have two different bases there. We have base of 2 and we have base of 3. Now, if you look at this one here, it's of base 2, while the power is 2n minus 1. If you look at this one too can be expressed in base 2. That is, it will be 2 raised to power 2n. So let's take those one with the same base. Let's take them together. Now, if we are doing that, that means we are going to have 2 raised to power 2n minus 1. Then when you take this 4 to this side, you are going to have 4 raised to power n rather. When you take this 4n rather to this side, you are going to have plus 4 raised to power n, which is equal to 3 raised to power n minus 1 over 2. When you take this to this side, it's going to become plus 3 raised to power n plus 1 over 2. Now, let's be careful in solving this question. Now, if you look at this, we are going to, from the law of indices, it is possible for us to split this from multiplication law of indices. We can split this to be, for example, let me say for example, we have a raised to power n b plus c. It is possible for you in indices to split this to be a raised to power b times a raised to power c. Yes, that's multiplication law of indices. Multiplication law. Now, if you apply this same principle here in this question, you are going to have this to be equal to, therefore you are going to have this to be equal to 2 raised to power n times 2 raised to power minus 1. This minus 1. Now, plus, remember that 4 here, this is the same thing as 2 raised to power 2 into n. That n is equal to this same rule we used here. We can use it here as well. The same rule we used here, we can use it here as well. Then we are going to have 3 raised to power n times 3 raised to power minus 1 over 2 plus 3 raised to power n times 3 raised to power 1 over 2. Now, this is the same thing as 2 raised to power 2n times 1 over, remember, this minus will change to 1 over, then you have your 2 raised to power of what? 1. Now, plus 2 raised to power 2 times n will give you 2n, which is equal to 3 raised to power n times this is the same thing as this minus will turn to 1 over, then 3 raised to power half, 1 over 2, plus 3 raised to power n times 1 over, times 3 raised to power 1 over 2. Let's still write it back. 3 raised to power 1 over 2. Now, at this junction now, this is what we are going to do. At this junction now, remember that if I multiply, this one is the same thing as 2 raised to power, this is the same thing as 2 raised to power 2n times 2 raised to power 1 is 2, right? Then this is 2 raised to power 2n, still the same thing. Now, this is going to give us 3 raised to power n. This is going to give us times 1 over, this will become root 3 plus 3 raised to power n times root 3. This half will become root on this 3. Then at this point now, remember that this 2 raised to power 2n will multiply this one to have 2 raised to power 2n over 2 plus 2 raised to power 2n, which is equal to 3 raised to power n times 1 will give you 3 raised to power n over root 3 plus this will multiply this, then you are going to have 3n root 3. Now at this junction now, I want you to take note of something. This place I want to use something here. I want to do something here. If you have, remember that if you have, let's say, let me relate it to an equation I just want to write down now. If you have something of this nature, for example, let's say you have something like this, a raised to power a over, let's say you have a over 2 plus a. It is the same thing as you saying, a is here, a is here. When you take out that a, you are going to have a outside, then into bracket. Remember, you've removed this a, then you'll be left with 1 over 2 plus this a. Now you've removed this one, then you'll be left with 1 here. The same thing applicable to this place too. Apply this same rule here. Remember that if I multiply a with 1 here, I will have a over 2. If I multiply this a with this one, we have what? A. Now apply the same thing to this place. You are going to have your, if you look at this place, why do we remove a out from here? We remove it because a is here, a is also here. Now this place 2 raised to power n, 2 raised to power 2n is here, 2 raised to power 2n is here. Now we are going to have this, back to the question, we are going to have our 2 raised to power 2n outside. Then we have the same thing as 1. We've taken it out, it will be, you left with what? 1 over 2 plus, you've taken 2 raised to power 2n out, you left with what? 1. Then is equal to the same thing applicable to this. 3 raised to power n is here, 3 raised to power n. If we take it out, we'll be having 3 raised to power n into 1 over root 3 plus root 3. Now let's apply 2 raised to power 2n. This one now, let's find the LCM here. The LCM is what? 2. 2 divided by 2, 1. 1 times 1, 1. 2 divided by 1, 2. 2 times 1, 2. 3 raised to power n into, this one is going to give you this over 1. Find the LCM. The LCM, you have your root 3. Then root 3 divided by root 3, 1 times 1, you have 1. Then this plus sign. Root 3 divided by 1, you have root 3. So root 3 times root 3 under surd is going to give you, that's multiplication of what? Surd. That's going to give you root 3 times root 3 will give you 3. For example, when you have root a times root a inside, is going to give you a. So this place that you have root 3 divided by 1, you know you are going to have root 3. That root 3 will now multiply this root 3. That is, this place we are having root 3 times root 3. Root 3 times root 3. And in that regard, you are going to have this to be. Therefore, I just cited this as an example to explain what we have here. Now, come back to this. You still have your 2 raised to power 2n. Now, this place, when you add it together, is going to give you 3 over 2. 1 plus 2, 3, then over 2. This is equal to 3 raised to power n. Now, this place is going to give you 1 plus root 3 times root 3. According to this place, root a times root 8 is a. Then root 3 times root 3 is going to give you 3. Then over root 3. Now, at this junction now, you are going to have this to be equal to this side, 3 raised to power n into 4 root 3. We only just added 1 to 3 and we have 4 over what? Root 3. Now come back to this. If you use this to multiply 2 raised to power 2n to multiply this, then you are going to have 3 times 2 raised to power 2n over 2 is equal to the same thing applicable to this. You are going to have 4 times 3 raised to power n over root 3. Now at this point now, let's cross multiply. We are going to have, when we cross multiply, we are going to have 2 times 4 times 3 raised to power n is equal to 3 times root 3 times 2 raised to power 2n. Now this is going to give you 8 times 2 times 4 is 8 times 3 raised to power n is equal to, this is going to give you 3 root 3 times 2 raised to power 2n. At this point now, let's use this to divide this and this to divide this. Then we are going to have 2 raised to power 2n over 8 is equal to 3 raised to power n over 3 raised to power n over 3 in 3 root 3 rather. Now look at what we have here. It's very simple. Don't be confused. Don't get confused. It is the same thing. Just that if we look at this expression, when we cross multiply here, it must equal back to this expression. That is, this times this. Remember, we are going to have this. This times this, we are going to have this. Simple. Now at this junction now, this is what we are going to do. Now 2 raised to power 2n over this one can be changed to 2 raised to power 3, which is equal to, now at this junction now, we have this to be 3 raised to power n over, this place is the same thing as you saying, let's change this one back. It's the same thing as saying 3 times 3 raised to power 1 over 2. This root change back to 1 over 2. Now at this junction, this is going to be 3 raised to power n over, if you pick one, remember there is 1, always 1 on this one. So any number standing alone is to a power of what? 1. Meaning this 3 standing alone here is to a power of 1. So when we pick a single base, this multiplication law of indices, when we pick a single base which is 3, then you are going to have 1 plus 1 over 2, and this is going to give you 3 raised to power n over 3. Remember, this one is going to give you find the LCM 2 divided by 1, you are going to have 2 times 1, you have 2 divided by 2, you have 1 plus 1 times 1. So this is going to give you 3 raised to power n over 3 raised to power 3 over 2. Now at this junction now, you can have this to be this in the same base. Is the same thing as saying 2 raised to power 2n divided by 2 raised to power 3, which is equal to 3 raised to power n divided by 3 raised to power 3 over 2. Remember, this is the same thing as saying 2 raised to power 2n minus 3. This will tend to minus, division law of indices. So you pick a base and y, you minus this from this. Then this is equal to the same thing applicable to this, 3 raised to power n minus 3 over 2. You get? So at this junction now, if I use this to divide this, if I use this one to divide this, then we are going to have 2 raised to power 2n minus 3 over 3 raised to power n minus 3 over 2, which is equal to what? 1. Because when you cross multiply, you are still going to have back this expression. Remember. Now, let me just find a little space here to finish the remaining, to get the final answer. Now, at this point now, this is what we are going to do. At this point now, let's write out what we have here out. Let's write out what we have here out now. We have 2 raised to power, remember we have 2 raised to power 2n minus 3 over 3 raised to power n minus 3 over 2. If you find the LCM here, what is going to happen? We have 2 raised to power 2n minus 3 over, what's the LCM here? The LCM here is 2. 2 divided, you put over 1 here. 2 divided by 1, we have 2. 2 times n, we have 2n. Then 2 divided by 2, we have 1. 1 times 3, we have minus 3. So at this junction now, we are going to have 2 raised to power this numerator, 2 raised to power 2n minus 3. Remember, is equal to 1. No? Minus 3 is equal to 2 raised to power 2n minus 3 over this place is going to give you, if you look at this place very well, you can rewrite this to be, this denominator here, you can rewrite it to be 3 raised to power 1 over 2 into 2n minus 3 is the same thing. So you get, is the same thing, which is equal to what? 1. Which is equal to 1. At this point now, you will see that, you will realize that what we have here now is now 2 raised to power 2n minus 3 over, this one is root of 3 raised to the power of 2n minus 3. Are you getting my point? Which is equal to what? 1. If we look at this, this is of the same power, and that's in indices. You have, if you have a raised to power c over b raised to power c, the law says it is the same thing as a over b all into c. So since this and this are the same, then you can say 2 raised to power 2n, no, you can say 2 over root 3 all raised to power 2n minus 3 is equal to 1. Now, if this is equal to 1, then all you need to do is to ensure that the base here is the same thing as the base here. So if I decide to use what we have here, all I just need to do is just to rewrite what I have here. That is, I will say 2 over root 3 all into 2 raised to power n minus 3 is the same thing now. So if I want this is what I want to calculate, and I have 1 here, then I can decide to put here and make it to a power of 0, which is the same thing as 1. That is 2 raised to power root 3 all into what is 0. In that regard, this is still the same thing as 1. So therefore I can easily cancel this now. Then I will have 2 raised to power 2, the power out 2n minus 3 is equal to 0. Then I will have my 2n add plus 3 to both sides. Then you have this is equal to 0 plus 3. So this will cancel this. You are going to have 2n is equal to 3. Then you have your n to be equal to 3 divided by 2. So n is 3 divided by 2. So don't forget to subscribe to this channel. More of these questions will still be solved here in a simplified form. So thank you.